Okay, there's a person is there standing at one end. Mass of the person be m1, mass of the plank be m2, and the plank is kept on smooth surface. Let L be the length of the plank, and this should be rough, no? Then only the person can walk on it. So by the time when you move from one end to another end, what is the displacement of the plank? Find displacement of plank when person moves from one end to other end of the plank. So how the friction force will act on this person? Like this. Then as it starts moving, and the friction force on the plank like this. So what will happen to altogether the plank? The plank will undergo displacement. The plank will undergo displacement. So let me take, this is the origin. It's a very basic problem. Let me take this as a reference. Where finally the person has reached the other end of the plank. Now, what is the displacement of this particular plank? Let me take this is x2. So look at now, the center of mass of the plank will be here. And what is the net external force acting on system along x-axis? Zero, no? The net external force acting on system along x-axis will be zero. So finally, shall we put L by 2 minus x2, this is this distance. And at what distance the person is will be L minus x2. These are the positions. So I'll identify what is the net force acting on system along x-axis, 0. And initially they are at rest. The person starts walking and the plank will shift over. Why plank will shift towards left? Because of friction. Friction on the person will be towards right, on the plank will be towards left. Net force is 0. So and initially what is the position of center of mass at rest? So finally it should be at rest only. And as net external force is 0, so delta xcm will be 0. No change in position of center of mass. So therefore xcmi should be equal to xcmf. Looking at this diagram, xcmi m1, where the person, let me choose this as origin. The initial position of person, let it be origin, or initial left end of the plank, let it be origin. M1 person is at origin, plank at a distance L by 2 by total mass M1 plus M2. XCMF, at what distance the person is finally? M1 L minus X2. Plank at what distance? M2 minus X2. Why minus X2? Anything you measure towards right will be positive. Look at X2 now. Sorry, this is a person at what distance will be L minus X2. What about the center of mass of plank? Center of mass of plank is at a distance how much? L by 2 minus x2 by total mass m1 plus m2. So m1 plus m2 denominator get cancelled. So m2 L by 2 in the numerator. So finally, when you solve it, I'll get the displacement of plank equal to how much? M1 L by m1 plus m2. What is this? Displacement of plank with respect to ground. What is the displacement of person with respect to ground? Earlier he was at origin. Finally, at what distance? L minus x2 the person is. So what is the displacement of person? Displacement of person with respect to ground. This should be equal to how much? L minus x2. So which is m2l by m1 plus m2. If you take the displacement of person positive, displacement of Planck should be negative. Already I assume that negative sign. Towards left is what we took it, no? L minus x2 has come. So like this, what happened? We can write expression for, you can find out how much distance the Planck has moved here. Now, without center of mass, can we solve this? We'll be in a big trouble, no? And where the center of mass of system will not shift. Where it is, it will be there only. So here Planck is, so it will be there only. Look at that, this center of mass of system, I'm putting a vertical line. Look at that, though person shifted, what happened? The center of mass. The center of mass has not shifted. Where it is, it will be there only. And what is this distance? You can call it as XCM. Look at center of mass. It didn't shift, no? Means, sir, every time we have to draw a diagram like this, every time we have to draw a diagram, we have to write equation, you can avoid this. You can directly bring directly a formula and you can manage here. You can directly take up a formula and you can manage the things. So what is the another approach? We know XCM equal to m1x1 plus m2x2 by m1 plus m2. Delta XCM m1 delta x1 bar m2 delta x2 bar by m1 plus m2. As net axial force acting on system is 0. So delta XCM 0. There's another approach. So therefore finally m1 delta x1 plus m2 delta x2 equal to 0. Now what is delta x1? Displacement of person with respect to ground, that one. So how do we can calculate how much the person has walked with respect to Planck? L, no. With respect to ground, m2L by m1 plus m2. Come back again, do observation. How much person has walked with respect to Planck? L. With respect to ground, m2L by m1 plus m2. So I'm going to use that relative motion. Displacement of person, displacement of man with respect to Planck is equal to displacement of man with respect to ground minus displacement of Planck with respect to ground. There's a formula, no? Displacement of man with respect to Planck plus L, it'll move towards right. Displacement of man with respect to ground, we don't know. Displacement of Planck, we don't know. The one which you don't know, just leave it. Okay, got this? This will be, so what is this? This is what? The delta x1. Oh, sorry. This is xm is what? Displacement of person. So I'll write it delta x1 minus x2. So what is delta x1 now? L plus x2 is what? Delta x1. And what is delta x2? Delta x2 is what? Displacement of the Planck with respect to ground, and that should be x2. Substitute these values here. Displacement of what is xp? Displacement of Planck. And what is xm? Displacement of man. All these are with respect to ground. Now let's use this formula. M1. What is delta x1? You can write it. L plus x2. Displacement of Planck, we don't know. Displacement of Planck, we don't know that one. So here is, it is like this. Look at the symbols. So they should be x2 equals 0. So therefore m1l m1x2 plus m2x2 equals 0. So what is x2 is equal to? minus m1l by m1 plus m2. What do you mean by negative? The plank will shift towards left. The symbols try to analyze. Look at these symbols here. The symbols try to see this one. Displacement of man with respect to plank equal to displacement of man minus displacement of plank. Xm is what? Delta x1. X2 is what? Xp, that one. Delta x2 or xp. So I think there are two approaches are there. No? Directly take help of this formula approach, or sometimes you need where you have to draw a diagram, look at initial position, final position, and you have to work out it. So you should practice either of the one. Okay, let me give one more case. So there are two persons are there. Let me call M1, M2, and there's a plank, let it be M3.